Hi, I'm Paul Battaglia, and this is section 9.5, the binomial theorem. At first glance, I think when teachers look at this section, they might actually say to themselves, why exactly are we placing it here? And it's really for good reason. There's some strong connections between the binomial theorem and the formula we use for combinations, which we'll see in a later section. I'm joined by Gabe and Brittany, and Gabe, I guess the best place to start is to talk about how we would like students to, I think, discover the binomial theorem and maybe work with it instead of just kind of giving it to them.
So as you said, probably one of the first big concepts in this section is the binomial theorem.
Okay.
And it's really something that's pretty easy for students to discover, maybe at least some of the patterns on their own.
Yeah, definitely.
So you could start by looking at like x plus 1 raised to the 0. It's all just 1.
Right.
X plus 1 to the first. Really nothing interesting happening here.
Right.
But once you start getting into x plus 1 squared, x plus 1 cubed, x plus 1 to the 4th,
Okay.
I wouldn't take this too far.
Right.
But probably once you get there, you start to notice some patterns with the coefficients.
Okay.
And students might recognize that along with you, they might not, so you might need to guide them a little bit, maybe point some things out to them. But really, this leads nicely into the discussion on the binomial theorem.
Right.
So as you're working through these patterns, you introduce the binomial theorem, you'll introduce the combination notation. I wouldn't discuss it too much here, as it'll come up in the next section or so.
Right.
But then from there, students might not like calculating all these coefficients. They kind of get tedious after a little while. So then you could really take it back to this idea of the patterns that we saw when we were expanding.
Right.
So something that might come up here is a nice discussion on Pascal's triangle.
Yep, I agree.
So you'll really want to focus on using Pascal's triangle alongside the binomial theorem to go ahead and expand these binomials.
Perfect. And Brittany, so we're trying to get a little bit more efficient here, and I know personally that my students will, take what Gabe said and the Pascal's triangle and then kind of like just run with it and make a lot of assumptions,
Yeah.
So Brittany, talk to us a little bit about what teachers should look for in terms of maybe some common misconceptions.
So the students, when expanding binomials, will forget to look at the coefficients of the terms. And so, for example, let's say we have the quantity 2x minus 3 to the power of 4.
Okay.
Well, the students won't pay attention that it says 2x, and then also that now it's minus 3.
Right. And see, these are good things to think about because, like we said before, not only now are the coefficients a problem, but even the signs. Everything is positive when it's not necessarily going to be that.
Yeah.
Hope these tips have been helpful for you. You find much success in section 9.5.